And I would like to take the last 15 minutes or so to open it up to questions from the audience. So I guess with that, who would like to ask one of the first questions? Go ahead, Lauren.
Sure. This is for Cameron. I wanted to just say that was a really interesting presentation. Doing it for the entire state of New Mexico was really incredible. Have you thought about how to take those ET numbers, turn them into some kind of irrigation or water requirement? Because I imagine you have additional water that's needed for the efficiency factor, additional water for salt management. So it's not just the ET, it's other things in addition.
If you could just repeat the question for people that maybe
I
didn't
think
hear.
the question was, have we thought about taking the calculations that we've made and actually estimated an irrigation requirement, taking account of efficiency and things like that? And no, not yet. I kind of wanted to stress in the talk that it was what we were calculating was kind of a minimum irrigation requirement, because we're assuming that all of that precipitation is available to feed that evapotranspiration that we're seeing. So I haven't thought about how we would do that. There's a lot of factors: deep percolation, there's runoff, there's overwatering. One thing we did do, which I didn't put in the talk, but the USDA, in addition to the cropland data layer, they put out this irrigation and water management survey every year. And just on the back of an envelope, I was able to, so for every state, they tell you the estimated applied water per crop. And so I did a quick comparison of what did we say was the estimated irrigation requirement versus what does the irrigation and water management survey say is the estimated applied water. And they were actually pretty close for most crops. I actually do have a plot somewhere. I don't know if it's in my talk or not, but so that's kind of a survey-based estimate of how much irrigation is actually being applied. And so our estimate is not that far off. We could look in probably detail on kind of like which crops we're underestimating versus overestimating, but I haven't done any of that.
Thanks. Great question. Next question. I know Rick had his hand up. If you want to go.
Yeah. Guess we don't have a mic.
Here. I do have a mic, actually. Just right here.
I don't know if my voice is strong or not. I had a question for Pam. Your method is basically a reference ET multiplied by a vegetation-based algorithm function. But one of your graphs, I think, was showing that over time, ET of riparian vegetation is declining. To me, that would suggest that per leaf area, the vegetation is experiencing more and more stress, as it's succumbing to less water. But using just straight greenness, might the leaf area remain similar? Apparently, your leaf area is going down too, but might the stress and reduction in ET be declining more rapidly than the leaf area, so that the multiplier on reference ET is maybe understating the amount of ET decline?
Yeah, that's a great question. It's always embarrassing to get a question by Rick Allen. So the other thing we found is that water use efficiency, right, can change depending on the species. So then the idea would be that you have these things like salinity and other affecting the ability for the plant, to thrive. So I believe that to answer that, yes, I would say that those declines were only basing it on greenness, because that's the easiest way forward. But on the ground, what we were seeing is some of this, like, I think I was telling you, so the sap flux, and then also in some of the eddy flux data, you would see peak phenology green up in July for big trees, cottonwood, willows, and then there'd be a leaf drop, and then a July, late August, maybe increase. And so we thought that the carbohydrate storage in some of these plants were holding on, right, to this ability for the stress when it was getting like 10-degree days for like 30 days straight, and then they drop their leaves, and then there'd be a little boost of leaf green up again. So it does very much follow the leaf area, but all we're doing is using, 30-meter pixels. And of course, higher resolution data would be great. And one thing I didn't get to say, it's a little off your question, is just that in doing it with only the optical bands and VI, we have these uniquely narrow corridors for these riparian species that the thermal bands aren't picking up at the 100-meter resolution. And so we were just trying to get a better estimate, and using the VI bands has helped tremendously in the riparian corridors, but you saw the stuff on shrublands and other areas. Then we're finding other things, like even if you're only using 30-meter pixels, you also have things like the precip, where it doesn't really matter so much in the first equations that we did for riparian. So, but I would say that soil salinity is also one of the stressors. There's a lot of things on the ground. I'm so honored that you asked me a question. Buy that mana beer.
Okay, next question. I'll bring around the mic.
Thanks. Great presentations by all. Just quick comment to Pam, and then a question for Kyle. It's funny, Pam, that you're arguing that it's all about simplicity relative to the other models. I think that a lot of us argue that our models are also super simple. PGJPL doesn't have stomatal conductance, and then metric is looking at hot cold, so we're always arguing which is kind of the opposite of a lot of our critics, where the models should have every little resistance and airflow pattern. So we also argue for simplicity is better as well.
I'm sure it's very
But
simple.
what would be interesting is you've been comparing to CBOP and I think the ensemble, but SIMS is VI based as well. So I'd be curious to see how it compares to SIMS, which is also a very simple model. And even PTJPL has sensitivity to the VI. So I'd be curious to see how it goes there. And then to your comment on Rick on the riparian corridors and thermal, with the hydrosat data coming up at 50-meter thermal and 20-meter Veneer, we can start to approach that riparian resolution. Question for Kyle, though. Very great talk, great work. It's always cool to see the presentation, which comes across different than reading a paper. And so you showed these parts where the eddy covariance was super high and super low relative to the models, or at least relative to the ensemble mean. Yet you also showed the range, and it looked like the range was actually hitting them, hitting those highs and hitting those lows. So I was wondering, is it one consistent model in the range that's hitting the highs, and then another consistent model that's hitting the lows? I'm curious to see what is going on under the hood of that range blob that you showed.
Yeah, for the most part, the models are consistent in the biases that we've seen, particularly when comparing to the almond orchards. And I guess that data set is more fresh in my mind just because we just published that paper, sent it in to get published. So I'd say the ones that are hitting the high marks tend to be metrics and CBOP, and the ones that tend to be on the low end is CBOL. And now, when I say the low end, I've noticed CBOL tends to be a little too low. If anyone remembers some of the slides when I was looking at the olives, for instance, the range tended to be very large, and there were some range markers that actually hit 1, 0, where you would obviously throw the data out, which is what the ensemble was doing, and that model tended to be CBOL. And then everything else was more or less right in the middle. SIMS tends to do a very good job in these systems, and I think that's simply attributed to the fact that it was kind of made for California agriculture and well-irrigated crops. And from what we've seen, particularly in almonds, is that they're well-irrigated, so that tends to align very well. Alexi dyslexy tends to do very well in vineyard settings where reduced deficit irrigation is a little bit more commonplace. It's very common in vineyards to deficit irrigate during different phenological stages to improve the quality of the grape. So they're not always necessarily interested in just getting the fattest, largest grape possible, which is kind of what almonds are more after. so we tend to see differences in the model in that point, but generally speaking, I'd say the upward bounds tends to be metric and CBOP and low end CWAL. To answer your question, Josh.
Is that related to, so what I'm particularly thinking of, because you showed a lot of graphs, was the effective heat off that desert going northeast. For that, where you have this extra energy driving the ET, was that getting captured by some of the models? It looked like it was in the range. And was that metric and
Yeah, I'd be hard pressed to say that it was being captured by the models and not just an overall positive bias in the model that just happened to capture the higher values at Vacaville because there was advection at that site. I don't know if it was necessarily capturing the advection or more or less better aligning with observed because it tends to be higher anyway. If that makes sense. And CBOT, yeah.
Great question. Thanks, Josh. We do have time for one last question if anyone has one.
Thanks. This is a question for Cameron, and I guess I actually have a pre-question because I'm not sure if I was interpreting this slide correctly. You had one slide where you were showing irrigation requirement for cropped and fallow land, where you showed, I think it was about 700 mm for crops and about 400 for fallow land. So the, I guess, pre-question is, was that the ET minus precipitation? So, okay, then that leads me to my actual question, which is that, I mean, just from a hydrological perspective, that wouldn't be possible if you have fallow land unless you're actually irrigating it. I mean, the only evapotranspiration you would expect is what's remaining in the soil, unless it's next to a river or has some other source. And that seems actually pretty high of a difference between the two for fallow land. So I'm wondering if you could maybe shed a little light on what you think might be happening in those locations.
Yeah. So the central tendency of that Bachton whisker plot was probably like 50 millimeters. There were definitely some pixels that were going way up. So that's the first thing. But I think there's several things going on. Number one, the cropland data layer is not perfect, and it's actually pretty strongly imperfect for some things. So that's one thing that's going on. So some of those pixels are probably misclassified. The second thing that's going on, and we did a comparison, and I mentioned it, but I didn't show the slide, of fallowed fields up in the upper San Juan, which sits up on a plateau that's pretty far up above the river, versus fallowed fields along in EBID and MRGCD, which are right along the river. And there was a very clear difference in the central tendency of the fallowed net evapotranspiration up high in the San Juan versus down along the river. So I think there is a lot of access to soil moisture and shallow groundwater from some of those fields. We also don't know anything about what a field classified as fallowed actually is. In some cases, it may be that it's classified as fallowed, but it's misclassified. In some cases, it may be fallowed, but someone's actually applying irrigation to it. We don't really know. And in the cases where we actually, the last slide I showed with the histogram of the, actually maybe that's the one you're talking about, the histogram of the pre and post fallowing, that was about 400 millimeters. We don't know what people were doing to those fields. All we know is that they were entered into this fallowing program and they were receiving funding in this fallowing program. And so some of them maybe have residual crops growing from previous years. Some of them might have irrigated once. Some of them we just don't know. And so I think if we had a much more controlled experiment where we kind of knew, like, okay, this field was definitely fallowed, nobody applied any water to it, nobody planted anything on it, versus this one, I think we could do a better job of really teasing out what's going on with those fields. Short answer is I don't know. That was a long way of saying that.
All right. Thanks a lot, everyone. Let's give our presenters one last round of applause.